broadly speaking, how different are the materials that you're using for that type of application versus maybe some other company working on those, like that medical wearables application? I know you mentioned kind of like TPU, thermoplastic polyurethane, is one of them, but we'd just love to hear more.
Yeah, for us, our the core technology that we use is just about the same for any of those applications. The main thing that I think is different is the trim. So we put our circuits underneath the trim. In automotive, that tends to be things like polyurethane-based leather or standard leathers, some thicker cloth materials potentially. And for something like a hospital bed, you're more doing like
Hello, everyone. Welcome to the It's a Material World podcast. I'm your host, Puneet, and joining me today is my co-host, David. What's new, David? How's it going?
Not too much. Just got back from vacation, which was nice. Took a week off, which was very relaxing, and spent time with family. So decided to get back into things. What about you?
Yeah, did not take a vacation. I think that's coming up later in the year, but yeah, exciting stuff happening. I think I'll be potentially moving soon. So just a lot to think about and a lot to consider as I get the moving process started. So yeah, I think we can just get right into the episode. We basically talked about E-Textiles and soft circuits with Madison Maxey, who's the founder and CEO of Loomia. And I wanted to hear your thoughts on kind of highlights, your favorite aspects of the episode, what to look forward to.
Yeah, I really like talking to her about the vision of smart textiles and what she thinks that will occur within the next 5 to 10 years, but more specifically talking about some of these novel applications and novel materials that struggle to almost scale at first due to lack of intrigue or even like knowledge of the material system, and how she's trying to create interest, create like knowledge so that people know that these materials are out there. Then people will buy it, and then she can make more and scale it to a more like easily attainable price. And so we had a slight chicken or egg discussion, and basically her key expert insight is if you just get more money, you can scale anything, which I thought was very succinctly put. But I really enjoyed hearing about her vision for scaling new novel materials and what it could be used for in the future.
Yeah, and I loved kind of the applications she was talking about. One of them was like medical wearables or apparel or even smart beds, just coming from that medical device background. That was particularly fascinating, but I also liked her discussion on kind of the automotive interiors side of things and how there's kind of a range, right, from in the flexible electronic space, super rigid, robust, all the way to like very, very like soft and flexible. There's kind of that range. And so the processing and the applications kind of differs between where you're at in that range. And so it's very interesting to hear what exactly these soft circuits can be used for in automotive interiors, as well as the medical space as a whole. And then kind of my final really highlight from the episode is just the advice that she shared, from her entrepreneurial background. How do you, start that? How do you start that company? How do you like go about the day-to-day? How do you balance that organization and that planning with also just kind of taking action and really just moving the needle each and every day? So that was a really cool discussion towards the end of the episode. So yeah, we talked about a lot of interesting tidbits and takeaways there. So without further ado, let's get into it.
All right. Hello, everyone. Today, I'm pleased to welcome this week's guest, Madison Maxey, founder and CEO of Loomia, a company centered around the manufacturing of flexible circuitry for smart textiles. Madison has an extremely unique background ranging from 3D printing and design internships to her work in entrepreneurship and textile circuitry. She founded Loomia in 2014 after studying design at Parsons School of Design for a semester before earning her bachelor's at MSE from Stanford. She has been recognized for her work in Forbes 30 Under 30, as a TED speaker, and as a Teal Fellow, as well as many other accolades. Madison, thank you so much for joining us today. We're excited to talk to you.
Yeah, I'm happy to be here. Thanks for having me.
Yeah, I'm super excited for this discussion, and maybe we can start by just defining some of your innovations, and specifically regarding soft circuits and circuit boards. So can you just describe what these electronics would be used for and the applications in which they're particularly like applicable, where traditional like circuits may not be good enough for those types of applications.
Yeah, absolutely. So, we call what we make an e-textile or an electronic textile. And I think when people hear the word textile, they automatically think of clothes, they think of fashion, and they want to know when they can buy like a light-up shirt. But in general, I say that our technology or these novel kinds of electronics solve electromechanical problems. So basically what that means is that if you are trying to make a product that has some electrical function, but also has some sort of mechanical requirements beyond just, having the circuit sit in a plastic box, then these new kinds of circuit form factors are really useful. And most of the time, there is no electromechanical problem for clothing. So when it comes to the applications where people are already kind of combining electronics and textiles together and need more performance, that tends to be places like automotive interiors or medical wearables and healthcare products. You can even think of things like smart beds for hospitals, or you can think of things like soft robotics, where you might need to have a very flexible circuit underneath something like a silicone film. So there are lots of different applications, but they tend to be places where electronics and soft materials are already meeting, and that can sometimes be a little unexpected for people, I think.
Interesting. So when we talk about it, you kind of described it as still a pretty broad term of just something that doesn't have to sit in a container. So could you go into the specifics about how we manufacture these different types of electronics? And maybe since there's such a large range, some of the common form factors versus traditional electronics.
Yeah, but there are lots of different ways to make these. So I think that that's sort of what's really interesting about the space right now, is that people are trying different techniques and they're kind of competing in terms of what's going to be the best. Standard circuits are generally etched, and that's sort of the state of the art. And then next from there, I would say there's printed electronics. That's printing something on like a polyester sheet. But when it comes to making more electronic textiles or these very flexible circuits, you generally want to print them on TPU, plastic polyurethane. And that has a whole bunch of challenges, because suddenly you're printing ink on this stretchy, flexible, floppy thing. The surface isn't completely flat, and you get different kinds of outcomes from your electronics than you do when you print on something like polyester, which is a little bit more known. Other techniques that people do are more on the textile side. That can be things like knitting conductive threads into structures or weaving conductive threads into structures. The kind that we do, we call it a conductive mesh. So we take sort of a unique, mesh-based approach to making our circuits. And so, yeah, it really just depends on what somebody needs performance-wise, what they need skill-wise, what they might choose in terms of the technology. But I think right now where the industry is that it's still open to new processes, and everybody's trying to figure out what's the best and, what each technique is good for.
What do you think is maybe the point at which we're at with current textiles or flexible electronics compared to traditional electronics? Of course, the complexity cannot be nearly as much due to we're figuring out how to print and how to make these. But maybe I don't really know how it compares currently to something we can print on a silicon chip.
Yeah, definitely. So I think generally these, one of the biggest differences, at least with the technology that we make, and I think for some of the more textile-based approaches, is the pitch. So something that you can put a lot into a very small area for a standard printed circuit board. For these kinds of technologies, you're generally doing a much larger surface area kind of circuit design. So they tend to apply to a different range of things, compared to what you can print on a silicon chip. It's nowhere near that level of sophistication or density. And yeah, I mean, in terms of the technology development level, I think things, silicon chips are being produced in such high volumes. I think for the most part, these technologies are being done in small volume applications, maybe 3,000, 6,000 units a year. I think that we're all still hoping and wanting to get to the place where they're, seeing really big volumes.
So then can you maybe give more context to the use cases, both in maybe the upcoming short term versus the long term? I know you talked about automotive interiors versus maybe like smart beds, right? What are like these e-textiles commonly used in now? And then what could they potentially be used in the future if we're kind of looking out versus looking right now?
Yeah, it also depends a lot on the technique that you're using. So, for example, knit E-textiles, as far as I know, aren't really used in automotive interiors very often. That tends to be more of like the printed solutions. But I do think by now people are using these kinds of novel circuit form factors for sports and like medical focused wearable technology products. I think that they're also used a little bit for automotive, but they're because the cycle's so long to produce something in the automotive space to get into a car line that we're still in development. They're not actually on the market yet. And then I think that like heating or outdoor goods with heating is a example of things that have actually been on the market for a long time. Like you could buy a heated jacket already, you could buy heated gloves already. That's been out for quite a while. Yeah, I mean, in terms of where things are going, what I hope for and what makes me excited about this space is that I hope that designers and engineers will see these materials as a tool in their product design toolbox. So right now, a lot of products, you think, oh, if we have some electronics, we're going to put them in a little box on the product. Like that's sort of the design rule. And I hope that with these new kinds of materials, product designers will think, oh, maybe instead of putting the user interface in a little plastic box, I can put it on the fabric of the product itself. I can kind of like build it in and integrate it better into the product that we're building. And so, yeah, I hope that that will be something that we'll see for the future.
Awesome. So speaking of design, it seems like one of maybe a pivotal or key experience in your career was your Autodesk experience. And, kind of that's a 3D design company. So I was just wondering, how has that experience, that work there connected you with your current career path and what you're doing at Loomia?
Yeah, so I was at Autodesk twice. Once I had a 3D printing internship there, and then once I had an artist residency back. And the residency to me was just incredibly inspiring. There were all these people there mixing together art or like design and incredible technical skills. And it just really gave me it gave me a sense of what it means to be like excellent at your work. I would see somebody who was maybe like 10 or 20 years my senior just producing something beautiful, like flawless, using these technical tools. So, they would like program something or 3D model something or use a CNC file that they developed using like parametric design techniques and make something just really cool. And it made me want to do better work. I was like, I also want to be able to do that quality of work someday. And then when I did my 3D printing internship, my manager was also kind of he was a mechanical engineer, but he did a lot of design work and just had really interesting ideas. And my project was, something that I thought was like very creative and a novel use of the tool. So I think it had a big impact on me for showing these kind of intersection places between design and engineering and how they can really feed one another. In some cases, if you want to make really interesting design work, it helps, some engineering. And, on the other hand, if you want to make amazing, thoughtfully engineered products that people actually want to use, it helps, some design. So that was a time that I look back on very fondly.
Awesome. Well, you also had an experience where your name's with Forbes 30 Under 30, and you mentioned in that interview that you have used materials like chip memory alloys and conductive ink for smart garments. What you're saying is it helps to know design, and so these are specifically useful when we're talking about making very novel, very interesting, very useful applications. However, they're very expensive. What are your thoughts on the ability to scale these products and the ability for it to exist in everyday consumer goods?
Totally. Yeah. So there definitely is a line between, kind of doing something to prove that you can make one of it and it could be cool, and being able to mass produce them at an affordable price point. And I think that is sort of the challenge of the entrepreneurial journey. You can be an entrepreneur who has like a designer art studio and not have that challenge. But I think if you want to make products that people use on the market, there are just so many challenges, especially in hardware. So, one, you have to make it work once, and then you have to make it work reliably. And then you have to basically like tear it apart and make it again so it can be cheap. And then you have to like sell it to customers, and the customers might want something different. So you tear it apart and you do it again to make the customers want it. And then you have to learn how to market and position it. So I think things like shape memory alloy in clothing, it's not something that's coming to market anytime soon. Like it's expensive and I don't think anybody really wants it. And I think that, these kind of like niche applications of e-textiles are things that can get to the market, but, getting the cost down and getting the volumes up and the quality up are some of the hardest challenges to overcome.
So as a designer, nobody really wants to scale these materials if there's not really a use case. But as a designer, if you make a use case and there's not an ability to scale, then it was kind of not wasted, but not a great design because now it can't be used for everyday consumption. I guess from your point of view and your experiences, how do you tread this line? And then how do you almost push for the change you want for these very novel materials that would be used in your next generation applications for e-textiles or anything you're working on?
Yeah. I mean, that's right. I think that, typically the way that people get around this problem is by getting, large amounts of funding to do something, because with money, you can kind of like push your thing into the market. You can artificially get the price down. You can kind of artificially create some level of demand through interest and excitement. That's one technique. And I think that the other technique is just during like very iterative development and process. It's like we do a lot of customer-based work. So it's like we have a customer who requests X and they're willing to pay for X. So we adjust our technology to give them what they want. And that gives us more information to then maybe make the technology more affordable or understand the use case better or something like that. So it's kind of like by working with customers, you take these small steps to better understand where the needs are in the market and how you can best feed those needs and how they work specifically with what you have. So I think it's, I think it's a slow iterative process. And I think that's one of the biggest things about, like when you read autobiographies of somebody like James Dyson, who started off, who sold vacuum cleaners, but it was all based on like a core technology innovation. It really took him a long time to have commercial success there. And I think that these things just do take a long time because of this kind of issue that you're mentioning, where it's like a chicken or the egg problem.
So Madison, I'm curious, I would love to learn more about kind of that market research, or, you talking to those customers. Do they come and find you? Do you find them? What does that look like? Maybe it's a mixture of both when you're trying to figure out your niche and your target applications and customers.
Yeah, for the most part, we have customers who will reach out to us. We also, if you're only operating your business on inbound, that's not a very good strategy. So, we also sometimes do outbound strategies and try and get ourselves out there as well. But yeah, generally the customers will come with like some idea of their application. And that's a really important thing to us in the early parts of that process, is understanding, do we think we can actually solve their need? Because if we can't, everyone will eventually realize that. It's better to tell the customer early, look, you don't need what we have, you just need some wires. And, solve that early than to get all the way down the road and help them realize it anyways. So yeah, it definitely is part of the, customer discovery process to understand the need. And we can kind of pattern match based on prior experience to know if we can actually add value, or if they should be looking at a different technology.
Awesome. And so I know you mentioned the different kind of manufacturing processes, even within the e-textiles space or the soft circuit space. And I believe you mentioned mesh as one of them that Loomia may focus in. What kind of industries does that enable, or is that maybe more suitable for? I'm curious what Loomia is targeting with your own technologies.
Totally. I wish I have like a slide that shows everything on like a quad table. It should be useful. Yeah, I think that it's often a trade-off between softness and robustness. So if you're doing something that's like knit or sometimes even embroidered into very soft materials, you're going to get a very soft circuit. And that's good for next to skin applications. Sometimes it's hard to pattern traces in a way that's good for things like, yeah, for making more complicated circuits. Because when you're working with a single thread, you can only make it move into so many shapes. So there's like, yeah, there's like the very soft side of the spectrum. And then there's the complete, that's like a knit E-textile. And then on the other side, you might have the hard spectrum. That's like a standard FR4 circuit, right? Just a rigid board. I would say where some are kind of like more in the middle, where our circuits are drapable, they're conformable, but they're actually they're like a composite structure. So if you put it next to your skin, you're not going to be like, this is fabric. It feels like a plastic film in some ways, but it's definitely going to be much more conformable than if you're using like a flux PCB, which only wants to flux in one direction. So we're kind of like a trade-off between that electrical and mechanical performance, where we have things like low resistance and good circuit design trace flexibility, but we also, are conformable and can do a multi-axis flex, which something like a flux PCB can't. And it depends so much on what the customer needs. We find that this combination of features is good for automotive, where there are very high performance requirements, but you also need to be able to wrap it around a surface or put it in a seat or put it on a wheel. We also find that it's good for robotics, where you might need flexible cabling or, some different kinds of sensing, where you also have a pretty high performance threshold, but it needs to also flex and bend in more than one axis. And then for things like wearables or more outdoor gear heated kind of stuff, we have pretty good heater efficiency, but there are definitely softer options out there. So it just kind of depends on what the application are. But yeah, or what the application is. But I would say these more like sort of industrial applications, we find that that's a good place for us.
Yeah, you mentioned like the flexible robotic arm. I'm just curious, like we already mentioned how the complexity is not as good as like a PCB, but how much design complexity does it add when the distance between nodes or everything is moving when you start to like move an arm and it will bend around a surface? How does that factor into the materials and then the design R&D needed to make a product work with high fidelity?
Yeah, and that there's a lot of design R&D that's needed. It also depends on the flexibility, on the application. So if you're just doing like cabling and the cabling needs to flex and bend, that's it's a much smaller set of problems than if you're trying to do like pressure matrices or a set of pressure sensors that have to curve around surfaces. Because each time that sensor gets bent, you might get a false reading. So how do you avoid the false readings but keep the sensitivity high? Does that become a firmware hardware challenge that you solve, or is it something that we can solve in the sensor itself? So, it depends a lot on what the functionality is in terms of like how complicated it is to have these kinds of moving surfaces.
Well, in terms of the wearable technology that you mentioned, especially for wearable clothing, I imagine one concern from consumers is that you're wearing electronics basically, and it could get very hot or it could do all sorts of things. How do you see the sentiment in your customers? And maybe as a designer and as a creator of these flexible electronics, what are your thoughts on it, and what do you want to convey to the consumer to let them know it's safe?
Yeah, and that's a good question. So we mostly don't work on those kinds of applications, but I think that the important thing is that most products that are getting all the way to the consumer level have gone through some sort of certification or testing. Like most electronics that you have that are sold in the US have gone through FCC testing and like some kind of UL testing maybe for the battery. And once you put electronics and clothing, it's also going to go through, a similar level of rigor to get to you on the market. So, if you trust that your phone is going to be safe or that your toaster is going to be safe, these things are also going to go through a level of testing to make sure that they are safe. And I think on top of that, the only applications where I think it's really worth the cost that it requires to add electronics into something that you wear, like some kind of garment, is that the need is really high. So, if it's a medical device or if it's some sort of like special training garment, then you're wearing it for a reason. You're not just like wearing it for fun. And I think that that's also kind of a helpful reminder that it's like it should be performing, it should be doing something for you as a useful, meaningful device, which is why you're wearing it. I think that if your choice is, maybe I can wear this normal shirt or my special wearable technology shirt today, but my wearable technology shirt might have some risks. That's one thing. But if it's like I need to monitor my heart at all times, and I can either wear this series of like sticky electrodes that are complicated and I have to rip off all the time to shower, I can wear this smart shirt. They both kind of have the same electrical risk, but the smart shirt's going to be much easier and more comfortable for you to wear.
Totally makes sense. So I know you mentioned the automotive interior applications and how that might be something that Loomia may be focusing on in the long term. And I was just curious what exactly that entails. I know you mentioned steering wheels, right? Or seating. What could flexible electronics or soft circuits in particularly be used for? Is it like sensing something? And if so, what is it sensing, whether it's a steering wheel or seating?
Yeah, of course. I want to be careful because there's some stuff that I can't talk about in too much detail. But I think like one thought process to, kind of consider is that right now a lot is changing in cars. And so, more electric vehicles are coming onto the road. And, your standard car gets warmed up, the interior for a normal car is warmed by running air over the engine. So, it's a combustion engine. That combustion generates heat, the air is warmed up, it warms the cabin, you're warm, everybody's happy. But in an electric vehicle, there's no combustion. So the only way that you can warm the cabin is by using the battery that's meant to drive the car to either support a heat pump or to support some sort of surface heating. So suddenly efficiency in heating becomes really important. And right now, a lot of the heated surfaces inside of a car are under like a layer of foam or so, because, they're not like these very flat circuits. They'll show through the trim of the car. And so you're basically like wasting a bunch of energy heating up the foam to then heat up the person. And if you could use some of these novel materials to get closer to the trim, you can heat people up faster with less energy, which means you have more battery for driving the car. These kinds of like engineering marginal improvements, right? You're like, this would be 10% better for our car. We can save 5% more range, and that's exciting to us. They tend to be like those kinds of things in the automotive space.
Cool. And then are I know you can't get into too much detail, but in broadly speaking, how different are the materials that you're using for that type of application versus maybe some other company working on those, like that medical wearables application? I know you mentioned kind of like TPU, thermoplastic polyurethane, is one of them, but we'd just love to hear more.
Yeah, for us, the core technology that we use is just about the same for any of those applications. The main thing that I think is different is the trim. So we put our circuits underneath the trim. In automotive, that tends to be things like polyurethane-based leather or standard leathers, some thicker cloth materials potentially. And for something like a hospital bed, you're more doing like coated, laminated materials, things that are bacteria resistant, can be easily wiped down. So oftentimes the A surface kind of changes based on industry.
Cool. Awesome. So then I know we talked about this a little bit earlier on in the episode, but I wanted to get back into this topic of scalability. Do you think that is like the main constraint that this field is facing as a whole right now? Like, is that something that limits this field's reach? Or if that's not the limiting factor, then what is?
Yeah, I think that David's question was kind of spot on, where it's more of this chicken or the egg issue, which also creates a trust issue. And I think that, at the end of the day, I think my view is that if money is there, people will solve scalability, right? I feel like it's very rare that somebody's like, I have $100,000 and I can't give it to you because you can't scale. Generally it's like you'll kind of solve it if there's money on the table, in my opinion. And these aren't like, we're not, a lot of this is like materials engineering, some is like materials science where you're doing a lot of low level development, but most of the time, we're not inventing things that are really that complicated. I think that there's a lot of ways to scale it. It's like a lot of iteration and testing for the most part. So yeah, I think that the issue is more of like engineers and designers don't know that these materials can solve their problems. And so they don't look for them. And since they don't look for them and they don't spec them in, then, they don't get the scale orders or the LOI that you would need to then really like get all of the manufacturing and kind of build the reputation of the space. And since we're not building the reputation, engineers and designers don't know that they can use them. So I think that there's almost like a reputational or marketing issue. Of course, there are lots of like tactical, tangible issues, but I think many times an engineer won't think an e-textile can solve my problem. And I feel like that's really what needs to start happening, I think, for things to move forward.
Wow, that's awesome. Well, let's say that things do start to move forward. What do you envision the impact of your technology having in 5 to 10 years? Maybe as more interest in, you can build up more of the scalability. What does like a perfect scenario look like for you guys?
Yeah, of course. I hope, I'm kind of rooting for everyone in this e-textile space. So that all of our stuff will. So yeah, I think for us, we're very excited about the idea of our technology making products or being part of products that people really love. And when you think of something like Gore-Tex, right, they make a waterproof, breathable film. The company W. L. Gore has like a million different products, and some of them are like life-saving, but I would say that Gore-Tex itself is not a life-saving material. But when people go camping, they're like, wow, I'm not sweaty, but I'm also not wet, like wet from the rain kind of thing. And that's nice. Like that's a product that people love. So I would love to see our technology used in like really thoughtfully designed, like functional products that people enjoy using. And to me, that would feel like we accomplished the mission.
Do you see that time frame that David mentioned, like that 5 to 10 years, being something where that vision is accomplished, or is that something that I know it just constantly evolves over time? But you mentioned like automotives. There's a longer development time. Same with aerospace. So I'm just curious with the soft circuits industry, what that development timeline looks like.
10 years is enough time to see that start to happen, because there are also some like very simple products, like some of these companies who make heated therapeutic back wraps sell like millions of heated back wraps every year. And I think that is using, like, I would say, a version of an e-textile. It's a wire sewn to a piece of felt, but it kind of limits the design of the product because of how it's done currently. So, I think that there are some like low-hanging fruit kind of opportunities. They don't have to be in a car. It could be like a much better, sleeker, more thoughtful version of a heated back wrap. And that would also be very exciting. So I think that's feasible within, 5 to 10 years.
Absolutely. Cool. So I know you've had such a diverse set of experiences with your career, and I would just love to hear if there's any specific piece of advice that you've received or anything you would want to share with our audience, like advice that you've received that drives you or has stuck with you as particularly inspiring. And that's maybe how I would love to wrap up this episode, is you sharing any advice for our audience.
Sure. Yeah, of course. I feel like I haven't, I feel like I'm not far enough along to give advice that I know works. It's like, if you just do this, it will work. I feel like but I do think that generally taking this mentality of like, how do you eat an elephant one bite at a time is pretty helpful for most things professionally, especially if you have like ambitious, I think for entrepreneurship, it's very helpful. But especially if you have like ambitious design or engineering projects that you want to work on, it's like, every day you take a bite, and that's how you make progress. And it sounds very simple, but I think that that's sort of what I've kept in mind through this entire time. And, that's how anything happens, like small pieces of progress over a very long period of time. So that's what I would share.
I love that. So this is just, I guess, a final question based on that piece of advice. But when you say take one bite at a time, there, to me, seems like there's a balance of, going ahead and taking action, right? Versus also kind of planning out those steps to a certain extent. You can't plan out everything, but maybe just laying it all out, organizing it helps kind of get it all out of your head. At least that's how I think of bigger projects. So how do you balance that at Loomia or in your past experiences, like the planning aspect versus just kind of jumping in and taking that first step?
Yeah, I mean, when I started at Loomia, I honestly did not have a very good plan, and I regret that. I wish I would have had a better plan, but I didn't really know what I was doing. So you just kind of get started. I mean, I try and balance it out much better these days, where it's like, okay, if I want to start a new initiative, I generally start by trying to like sketch out the concept, and then I really like to use Gantt charts. So it's like, okay, if I think that this thing could be done in 6 months, let me sketch that out on a Gantt chart step by step and see if it happens in 6 months. And then when I realize that it doesn't fit, it's like, okay, maybe it will take 12 months. And then once I kind of have an idea of the things that I'll need to do along the way and what I might need to make something happen, then it's like, okay, each day I will look at this Gantt chart and be like, my task for this week is this. Let me just try and do a little bit towards that task and see if I can get a little bit closer to making it happen. So there definitely is kind of like a planning part. I also listened to a podcast recently that I really enjoyed with like Seth Godin, the marketer, which is different from product development, but it's just like each day, if you can push yourself to do the hard thing, that is where you will make progress, right? So I think within that, take a bite each day, it's like, okay, what is the thing that is going to be high value that I may not necessarily feel like doing? And let's try and do that. And if I do that, that's enough for the day. That's fine. And yeah, so I guess there are like different parts of that idea. But yeah, I think a big part of it is just like doing something. I think a lot of times people just don't actually act on the things that they want to do at all. And if you do that for months and months, you will not get the thing that you want. So it's like good to just do something.
Absolutely. Yeah. I love that. It's like, what task can you accomplish today that moves the needle? And then on the flip side, if you can continue to do that day in and day out, then you'll definitely see progress over the long term. So I love that, Madison. Thank you so much for joining us today and just sharing your experiences and sharing more insights about the world of soft circuits. We really appreciate it.
Yeah, it's my pleasure. Thanks for having me.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.